Our next speaker is, I hope I pronounced it correctly, Ricardas Jonaitis, who works for Lime Microsystems. So Lime Microsystems makes software-defined radios. And Ricardas works as a software developer for the Lime Suite NG, which is basically the API to talk to the software-defined radios. Lime Microsystems is also in the 6G for All project. So yesterday we already had the presentation from NXP. And yeah, Ricardas will now talk a bit more about the radio, and we'll talk about the Lime SDR micro and integration with OAI.
Thank you. Hello, everyone. I'll try to keep this fast as possible. So I'm a software developer at Lime Microsystems, and I'd like to do a short recap of who we are, what do we do, and what is our current latest product. This is a short overview of the presentation, but since we're ahead of time, I'm just gonna go straight to the point. So we're a small company that over a decade grew to 28 dedicated engineers, and that have deployed more than 20,000 units of our SDR products worldwide, with the goal of democratizing the mobile networks development, research, and education, while trying to minimize the cost for owning and working with wireless communication developments. We started with our own IP for RF chips with the initial design of LMS 6000, which currently is at the end of life due to the advancements of manufacturing technologies. So we have another design, LMS 7000, that is currently shipping in volume, and LMS 8000 design that acts as a companion to up-convert into higher frequencies. For the future, the designs include combining these technologies to provide even more bandwidth and higher frequencies reachability for the upcoming future communication protocols. All these chips are utilized in our own reference designs that essentially became end products as a SDR plugin boards. We started with the initial implementations of USB format and then transitioned into more capable PCI Express-based solutions that progressively provided more and more functionality. So our product lineup essentially consists of low power, cheap SDRs up to a server-grade, network-ready solutions. We also provide a fully deployable and ready machines, depending on the required computation capabilities. We can provide a small factor portable systems or a rack-ready enterprise-ready solutions. Our latest upcoming product is a Lime SDR Micro that is based on a different design than our previous SDRs. Up until now, we utilized FPGA-based designs, and currently we are using NXP's LA9010 baseband that provides a dedicated control ARM core and a vectorized DSP chip. We are aiming to provide deployability to as many systems as possible. So the form factor is M.2 22 by 80. One nuance is that the RF shielding is a little bit higher than the M.2 spec. So that has to be accounted if the goal is to put it into tightly enclosed laptops. It's fully reprogrammable. Everything's about it open source. It can operate as a raw IQ samples provider, or some of the physical processing can be implemented on the chip to reduce host CPU utilization. The Lime SDR Micro essentially provides one transmit and two receive channels. There's also two additional receive channels that can be used for direct sampling applications or connecting to another external baseband. All of this is based on the LMS 7002 chip. So any previous applications that utilized our solutions can flawlessly transition into using LimeStar Micro. So all the firmware is open sourced, and XP provides a license-free toolchains and simulator capabilities for rapid deployment and evaluation of the processing designs. The NXP provides implementations for FFT, inverse FFT, and QAM demodulations. All of the projects are based on CMake system, so everything's automated, no need for specialized tools installation. You just download the project and run build command. The software that we provide provides all kinds of command line tools that can be used for remote control of the device, provides basic transmit and receive capabilities utilizing files, and provides an advanced user interface for advanced tuning and configuration of the chip parameters. The integrations into other softwares, we provide a native integration into GNU Radio, OpenAirInterface, other 5G stacks like Microsoft, SLSRun, and a plugin for SOAP-SDR that can extend the integration into many other software products. We have our own OAI fork that is tracking the upstream development, and we have integrated natively LimeStar Micro support. We are planning to upstream our plugin once we finalize and optimize the API usage. The current design is validated on x86 system. The software layer is fully operational and capable. Running LimeStar Micro, it was proven to run in FDD mode, but we still have some nuances to fix for TDD operations and long-term stability. So the OAI design that we are testing, we are running 20 megahertz TDD configuration. The long-term stability requires implementing a GPS DO and improving timestamping capabilities. So the roadmap is we have launched a crowd supply campaign, and we intend to deliver the orders by the end of September. After that point, devices should eventually become available to public. Until that point, the drivers and the firmware support is expected to be improved significantly, and some physical layer processing should be offloaded onto the chip and reduce the requirements for any host system. In the future, there are more LimeStar Micro variants planned that include some additional front ends and adapters, for example, for HF sampling at the frequencies from 0 to 30 megahertz. Thank you for your attention. Any questions?
Yeah, regarding that that front end there that goes up to 12 gigahertz, you have any SDR boards that employ that tool?
The 12 gigahertz?
The 8001, the LMS 8001.
Yes, so the LMS 8001 can go up to 10.5 gigahertz.
Okay, 10.5. Do you have any SDR boards that have this integrated?
We have a companion board that can act as an independent up converter, down converter. So it can be used with any other SDR board. But to have LMS 8 integrated on the board itself, we haven't released those products yet, but we are already working on those.
Yes, it is just a converter.
Yes, LMS 8 acts as an up-down converter.
Oh, okay. So you need to generate the signal at an intermediate frequency to.
Yes.
Okay.
So one of our upcoming products combines the LMS 7 plus LMS8 chips. So LMS7 generates the modulation, and the LMS8 upconverts, downconverts to the final frequencies.
Okay, thanks.
Another round of applause for the speaker. Thank you.